Here we go. So for today, it's applications of logs. Big picture, first thing I told you about logs was that you needed logs for something like this. And then you could rewrite into a log. Then I told you how to graph them. Then we solved a bunch of log problems that had like a log base x of 2 equals 3, that kind of thing. And then today we're going to have a word problem. We've got to figure out which way they're trying to give us the info. Are they giving us an exponential like this or a log like this? All right. So let's just do a little review. Would you please write the log for that? Take a second and just write the log for 5 to the x equals 8. That's a log. And then since you have your graphing calculator out, you should be able to tell me the answer by using a log, typing it in. And some of you will be able to use Math Alpha Math. And if you try that and it doesn't do anything, then you have the old software and you'll have to enter it as one log divided by another log. Did you know this was log base 5 of 8 equals x? Raise your hand if you already had that. Awesome. Then put it in your calculator. You just did the circle of logs. That's how I would describe that. And then to put this in the calculator, if you have forgotten, if you have the old style calculator, you've got to do log 8 over log 5, and you'll get a decimal. And it should be like 1 point something, because if you look at this, you could tell 1 would be too small, 2 would be too big. All right, Mr. Albright, what did you get for the decimal? Mr. Albright?
I don't know where the log is.
Okay, do you have your calculator?
Yeah, I do. I have it on
All right,
my sleeve.
so I said Math Alpha Math. You must have missed that string of commands. I'll come back to you in a minute. I'm not trying to burn you. I just wanted to see what the answer was. Max, do you know the answer for this log base 5? 1.29? Can anybody verify that?
Yes, I can.
All right, good. All right, so that's just a little review of the basic log. How about this one? Could you rewrite that one? Brody, what'd you rewrite it as?
Is it 2 cubed equals x?
Nope. Thank you for trying. It's the circle of logs. X to the third equals 2. All right, and then you could put this to the power of 1/3. So the final answer is 2 to the 1/3 power. That, again, is something you should know how to do in the calculator. And some kids think, well, I'll just type 2 to the power of 1/3. And your calculator says, sure, I'll do 2 to the first, and then I'll divide it by 3. And that's not what you want, probably, right?
Did you do alpha?
Now, some people with newer calculators, it'll know that you want the 1/3 in the power. But with the older version, again, depends. Which version do you have? Everybody do it and see whether you needed parentheses or not. Because if you get the different answer than I do, you probably should have used the parentheses. That's fantastic. Did you get 1.2, and it would round to 1.26? Raise your hand if you had 1.26. All right. If you don't get 1.26, maybe you weren't putting it in parentheses. Okay, so are you saying you found an easier way to do this problem from the start?
I found an easier way to improve the power instead of having to do parentheses.
Okay, so tell me how to put this in better than parentheses.
So, when you look at the alpha button,
Yep,
and next to it for the where you do like the x and the n.
yep.
If you do alpha and then that button, after in the power slot, it should give you the option to do a fraction.
It's the same thing as division.
I think it's the same as the Math Alpha Math thing. Kind of, where it pops up an empty spot where the X is. I do like it. I think it's interesting. I wonder if when you type in, tell me this, on your calculator, because they all have different software, right? On your calculator, get out of that for a second and just type in X, regular X, to the power of, that the X that's right next to alpha, and hit the power of button. Does yours go up and make a little box right here? Okay, so see, it's not the fact that you did it that other way, it's the fact that you have the new software that then gives you that little box. If you don't get a raised blinky box, the people with the old calculators, they can't do what you just said. So if you've got the new calculator with the new software, then Math Alpha Math gets you to the same spot. Oh wait, that's for logs, sorry. Then just X with the power of thing gets you to that same spot. So either way, you're right, your way worked. I would just dispute if it's better, just because it depends on if you have the new calculator.
Yeah, the power of these two boxes for the alpha, for the both parts of the fraction. The alpha.
I think I see what you're saying. So
Yeah,
you would
it's
do,
the fraction.
you would go,
And it takes it as the fraction.
okay. Then I'm going to move on because what we're really talking about for today is this. I have found this to be fascinating, and I'm the one who made this slide for today's notes. I found a picture of a really steep beach. I've seen this myself over the years where I've traveled, and some beaches are really steep like this. Like when you walk down to the water, you're practically falling in because it's really steep. And other beaches are super flat. And I never knew, don't interrupt
I'm just keeping my hand up because I have a sprained thumb.
Okay, all right, I will ignore your hand with the sprained thumb. Thank you. Never had that one before. Okay, so steep beach. There, I found this log equation that tells you that the slope of a beach is related to the average diameter, d, in millimeters, of the sand particles. So basically, how big the sand is tells you how steep the beach will be. And I did notice that when I was in like Hawaii, they have really steep beaches and the sand particles are really big. If you pick up a scoop of sand and you look at it, it's almost like they're little tiny rocks instead of like teeny tiny flecks of sand. The ones that are teeny tiny flecks of sand have a really small diameter, right? And those are very flat beaches. So this angle here, like how steep this is going down to the water, that angle is almost nothing at like Fort Myers Beach because the sand is so small. And really big sand particles give you a bigger slope. So here is your equation. Now what I have found is anytime we give you a complicated equation on a test, your only job is to stick numbers into it. So if I gave you the slope, you'd put it there. If I gave you the diameter of the sand, you'd put it there. And then your only job is to be able to type this into the calculator. Well, log base 10 is just log on the calculator. There's a button called log. All right. And so if I give you a diameter of 0.25, I hope you could put it right there. And then log base 10 means just log. And you do the log of it. And then you'd times by this, and then you'd add that. See if you can do it and get the answer. How slope would the beach, what would the slope be of that beach? Remember, if you just hit the button called log, it's doing base 10. I'm rounding, but did anybody else get 0.088? Raise your hand if you did. Awesome. That's the slope of that beach. Now they're going the other way, of course. They're giving you the slope. And here we are doing a real world log problem. In the real world, you could look up this formula and you could figure out how steep that beach was, because you could grab a piece of sand. Granted, you'd probably want to average it, so you'd grab a few pieces of sand and average out their diameters, and you could actually do this to see how steep the beach is. This time the 0.125 goes in the only other spot that it could go, which is right there. So to solve this, I would start by subtracting the 0.159. Then I would divide by the 0.118. And now, after I subtracted the 0.159 from both sides, and I divided by the 0.118, I now have negative 0.288 is equal to log base 10 of D. Did you get it that far?
I didn't get -0.288.
All right, then you should try 0.125 minus 0.159 and then divide by 0.118 on both sides. And I think you'll get negative 0.288. I had multiple kids say they got the same thing, so I think I'm on the right track. And now I'm going to go 10 to that equals that. It's that circle of logs again. You notice how often we use that? That rewrite it from log to exponential form is so huge. 10 to the negative 0.288 is equal to D, and that's something a calculator could do. I got 0.51. Raise your hand if you had that. Yay. The diameter would be 0.51 millimeters, half a millimeter. Okay, now you know how steep the beach is. Depends on how big the sand is. All right. Another one that I'm proud of having made these slides because I really think it's cool how the math in the real world works. Decibels is this equation, and you guys all can relate to decibels. There's some people, this is one of the things about something, a super quiet sound that is kind of fascinating to me, is that some Buddhist, I think it's Buddhist monks, say that they can hear grass growing. If you listen close enough, you could hear something that quiet. It doesn't seem possible to me, but... And then on the other end of the scale, there are noises that are so loud that if you heard it, it would kill you. I know that doesn't seem possible. I'm not just talking about going deaf. I think you know that a noise loud enough could cause you to go deaf. But the thought of a noise so loud it could kill you, it's not that your ears would like rupture and you'd bleed to death from your ears. It's actually that loud of a wave would mess up your body so much that you would die. You can Google it. Is it possible to die from a loud noise? And it's, they say that whales, for instance, make such an insanely loud noise that if you were in just the right spot, that hearing that could not only cause you to go deaf, that it could kill you. And maybe it's the fact that you're underwater and it would stun you and then you would drown because of that. I'm not sure. But just the thought that a really loud noise could kill you is kind of fascinating to me. All right, so here's this really crazy looking equation. But once again, it's only got two variables. It's got D and it's got I. And they must define those somewhere. Decibel level is this. And I is the sound intensity measured in watts per square meters. So if the whisper has an intensity of this, that needs to go there. Everybody figure out what the decibels would be for that. This is obviously super quiet. It's like a whisper. If you're not sure how to put this in the calculator, the EE button can be used to put in times 10 to a power, or you can just type it times 10 to the power of. So I'm going to put that in first, and then I'm going to divide it by 10 to the negative 12th, and I'm going to get a decimal. That's how my calculator says 5.4 times 10 to the negative 10th. Then I'm dividing by 10 to the negative 12th. And when I did that, I got 540. Anybody else get 540? Cool. Now I've got 10 times log base 10, which is really just regular log, of 540. So I'm going to do log of 540, and then I'm going to times it by 10. I got 27.32. Anybody else get 27.32? I did log 540. This is just log 540 because, you know, that means base 10. And then you times it by 10. Don't forget the times by 10 in front. So it's 27 decibels. Any questions on that? Okay. One more. This is about pH. Again, logs coming in on pH. You guys know what the pH of water is? 7. Very good. It's one you just kind of memorize. Do you get that some things are more acidic than water and some things are more basic than water? 7's like right exactly in the middle. All right, something more acidic would be like pop. And it's kind of like, to me, it's kind of crazy that pop is so acidic that if you pulled out one of your teeth and you put it in a glass of pop, like Coke, that it would only take a few days and it would have melted your tooth down. It would be gone because pop is that acidic. Oh, I drink pop all the time. Why have my teeth falling out? Well, they have slowly eroded a little bit because of the pop I've drunk. It's just a fact. If you're drinking pop, pop is acidic, some more than others. You're slowly eroding off just a tiny bit because it just washes past your teeth for a second. But if you took your tooth out and put it in pop, it would dissolve. It's kind of a crazy thought to me. On the other hand, some things are super basic, and those are really caustic also. So chlorine bleach is super basic, and things that are super basic combined with the things that are super acidic can make poisonous gases. So it is possible to, by accident, people have done this, mix chemicals at home that they're like cleaning supplies, and one of them is super basic and one of them is acidic, and then they get poisoned from that. So you really have to be careful with that. Like, it gives off a poisonous gas. So this is an example of another formula. I'm going to just skip over this one, but the base scale, that's something that would come from log. They're all based on log. And one of my favorite ones is the Richter scale. Have you guys heard of the Richter scale? All right, I'm going to pause for just a second. Okay, I'll talk about the Richter scale more tomorrow. So here's another formula. They gave me two letters, P and T T is the number of years after 2011. And believe it or not, since we made this slide, we have found out more about world population. And it's no longer just like, oh, look at it go up like crazy. The world population is slowing down. And we don't think we've reached the peak world population, but judging by how fast it's slowing down, it is possible that we have reached it or are going to reach it in the next couple of years, where all of a sudden that's the highest it ever was. Like forever? It is possible. Why? Well, because people are choosing not to have kids. And if they don't have kids, we'll just keep it simple. What if nobody had a kid anymore? To get the world population would eventually die out, like literally go to zero. If everybody as a group decided we're not having any more kids, ever. It's just simple. If there was no more births, then people would only die, and then the humanity would literally go to zero and we'd all be gone. It's a crazy thought. But is everybody doing that? No. But they're not having as many kids anymore, such that the population in a lot of countries is actually declining dramatically. Like in Japan, for example, and in South Korea, those two countries, in like 20 years, they're going to be half as big as they are now. And go another 20 years, they're going to be half as big as that. Go another 20 years, if this thing continues, eventually these countries literally will get down to like 4 people. Like, it's insane. So anyway, world population has definitely changed a lot. The discussion about it because of just crashing birth rates, or fertility rates is I think what the right way to say it. So, okay, moving on. I think this one is nice, simple one that I think you could do without my help. Try to figure out, there's 2 variables. Don't get confused by that. That's just like a y. That's, like f of x is just one variable. And here's the other variable. Try to answer this question. And if you get stuck, I'll show you how to do it in a minute, but give it your best shot. Okay, so after how many hours would they expect to have 3,000 bacteria cells? All right, 3,000 to me sounds like they're not giving me a time, they're giving me a count. So like they're saying that's 3,000. So then I would have had an equation of this. I would have divided both sides by 100. And that would give me 30 equals 2 to the t over 15. Then I have to do a log. If you right here didn't know what to do, I understand. But the whole point of logs is to be able to rewrite things like this. Log base 2. And then you do the circle of logs. You got to go over to this side of 30. And then come back here equals t over 15. And then one of my favorite things, clear fractions. I'm going to multiply by 15 on both sides. And that cancels, and t's alone. 15 log base 2 of 30. Can you put that in your calculator? Well, I personally would have started with this, and then I would have found log base 2 of 30, and then I would have times it by 15. If you have the older style calculator, you should have done log 30 divided by log 2. That would have done it. Otherwise, on my calculator, I can go math alpha math, and it pulls up a log right away. I can put in the base 2, the other number 30, and then times that by 15. And I get 73.6. Raise your hand if you had 73.6. Nice. Yes.
I just want to know, so on the start, where's the T on the left side?
All right. This was, I tried to explain it as like, this was like f of x. That is a variable. It's just a variable. It was a c of t. So this is just a variable. Just so that's where you put the 3,000 is in there. Okay. So that's 73 hours because it says give your answer nearest hour. So I guess 74 would be the right answer if I'm going to go to the nearest 1 hour. Okay, I think you've got the idea, and we have a worksheet like this. Everybody find that worksheet. I'm sure some of you have already started it, and so I won't like throw out problems 1, 2, or 3 because some people have probably already completed those. But let's look at the worksheet together. I'll tell you which ones we might be able to skip. Yep, you may skip all of 4 and 7 part B. Now, could you do such? Sure, you could do all of them, but I'm not going to require you to do those. I think you're going to find that they give you a number, you stick it in a formula, and you solve for the other one. That's usually how these go. All right. So let's get started. Just do the first part of number 1. Could you read me number 1?
Me?
Yes.
Antlers set in inches and shoulder height H in inches of an adult male elk are related approximately by the function H equals 116 log
H equals 116 log
base 10
base 10
of parentheses A plus 40
A plus 40
close parentheses and then minus 176.
minus 176.
And part A is asking for the shoulder height of an elk with a 60-inch antler spread.
All right, so this could happen because you find antlers on the ground. Like literally, they just shed them, and then you're walking through the woods, and all of a sudden there's like this big set of antlers there. And that's pretty cool. So you grab it, you measure it, and you go, oh, these antlers are this big. Now you can tell how big the animal would have been. All right. So if the antler is the A, and they told you that was it 60? Did I hear that right?
Yeah.
Okay. Then I can do this in my head because it's really nice. Would you agree that 60 plus 40 is 100? Would you agree that 100 is 10 squared? Why would you do that? Because this, if I can make that 10 squared, then the bases are the same. I got 116 log base 10 of 10 squared, same as 100, minus 176. I'm going to do this part because it's just 2. Log base 10 of 10 squared, that's 2. 2 times 116, I can do that in my head. 232. The last thing I really don't feel like doing is 232 minus 176. I'm going to use my calculator to get that. And some of you probably are already done. 232 minus 176. And I got 56. Did anybody else get 56? Yay. Okay. What is that? That if this was the antlers, then that must have been the shoulder height. It's pretty tall. All right, I think you've got the idea. Let me know if you need help. I'll happily help if you walk on up.